Okay, so we've got the Chapter 5 review for Trigonometry / Pre-Calculus. Chapter 5 is all about trig identities and solving trig equations, so here we go. Now, we do start off with some review problems from Chapter 4, actually. So this asks us if tangent theta is 24/7 and cosine theta is less than 0, find sine theta. And so what we have to do with this is think about what quadrant this has to be in. And there's some different ways to do it, but remember that tangent is our y value over our x value. And in order for us to get a positive 24/7, one of two things has to happen. Either both of those things are positive, which would put our triangle in the first quadrant, or both of them are negative, which would put our triangle in the third quadrant. And so the way we figure out which of these two triangles it is this second piece of information. Cosine theta is less than 0 means that cosine is negative. And if cosine is negative, we have to think about what does that go with, x or y. So cosine goes with our x because it's our left and our right, which is our adjacent side. So that means that it's not this one that's in the first quadrant, it's the one over here in the third quadrant. So my y value is negative 24, and my x value is negative 7. So to find sine, which is what my question is asking, I need opposite over hypotenuse. So I know opposite is negative 24, but I don't know the other side, so I'm going to have to Pythagorean theorem that. So a squared plus b squared equals c squared. So negative 7 squared plus negative 24 squared is 625. And then I square root both sides and I get 25. So that means my hypotenuse over here is 25. So now I have all the information that I need to finish the problem because I need sine, which is opposite over hypotenuse, or y over r. Either way we think of it, this would be negative 24/25. So you may notice, especially if you did this problem yourself and got positive 24/25, that it's really easy to miss this if you're not paying attention to the second piece of information. And so that's kind of what's being tested, is this idea that there's not just one place where this can be positive, there's actually two places, and so we have to have more info in order to decide which place it's in. So example 2 is really similar. On example 2, we are going to set up our triangle. And so negative 5/12, this is tangent again, so it's y over x. And so we're either going to have to put the negative with the 5 or with the 12. So where does that happen, that tangent is negative? Or if you need to think of it as when is y negative and x positive, and the other situation is when is y positive and x is negative. Or look at the problem before this and say, well, it's got to be the other two places. This is an option. This is an option. So we have to decide which of these two things is the case based on our second piece. Sine theta is greater than 0 means that sine is positive. And so if sine is positive, then that means that y is positive, which means our triangle is the one that's in the second quadrant, not the one in the fourth. So my y value is 5 and is positive because it's going up. My x value is 12 and is negative because it's going left. Then I would Pythagorean theorem. And I get 169. You may have known this one already, because it is a Pythagorean triple. So is the last one, but the one before this might have been harder to remember. Sorry, had to sneeze. So the hypotenuse is 13. They ask us for cosine, which is adjacent over hypotenuse, or x over r. And so that gives us negative 12/13 for our answer. Now we're going to use the properties of inverse functions to evaluate the expression. They say arctan is x, and the first thing we need to do is make that a fraction. So the arc part of this means that they're telling me the opposite side over the adjacent side of a triangle. Normally, when it's just tangent, we have an angle inside. But because it's arctan, they're telling us the opposite and adjacent side. So I don't need to draw quadrants, although I can if I want to. I just need a triangle. I need to label an angle for my perspective, and then I need to put the opposite side as x and the adjacent side as 1, which looks like this. Then I'm going to Pythagorean Theorem, so 1 squared plus x squared equals my hypotenuse squared, and so I'm just going to use c to represent that. So 1 squared is 1, x squared I can't do anything with, and then to solve for c squared, I need to square root both sides. Here's a mistake that a lot of people make. I cannot simplify the square root of 1 plus x squared. Most of the time when we're simplifying it, it's because of a misconception that we have. If I had 1 times x squared underneath a square root, yes, that would be 1 times x. But as soon as I change this to a plus sign, it does not work, because taking the square root of an algebraic expression like this is us saying, like, how can I multiply two things together to get 1 plus x squared, two things that are the same thing? Okay, like when I do square root of 4, I'm looking for what are the two things that multiply together to get 4 that are the same. And that's how I get 2 as my answer. And so it turns out there's nothing that this factors into. And so that's why we can't simplify it. And as long as you can just remember, hey, my square root's not going to simplify, it actually makes it easier. So you don't have to worry about simplifying. But that's our hypotenuse. It wants us to tell them cosine of this. So that's adjacent over hypotenuse, which is 1 over the square root of 1 plus x squared. And then I'm going to rationalize that so that my square root's not on the bottom anymore. So I multiply the top and the bottom by the square root on the bottom, and I get 1 plus x squared under my square root on top, and 1 plus x squared without the square root on bottom. And that's my answer. This is also from chapter 4, the amplitude and the period. We've got a sine function and a cosine function, and so what we have to remember is that to find the period is 2 pi over b, and b is what's in front of x, or theta. The amplitude is the number that's in front of sine or cosine, but it's the absolute value of that. So when I look at this for my amplitude, I'm not going to write negative 1/6. I'm going to write positive 1/6 because amplitude is never negative. When I go to write the period of this, I'm going to put 2 pi over what's in front of theta, which is 4. And then I'm going to simplify this so that it is pi over 2. And that is my answer, 1/6 and pi over 2. So it may not seem like a big deal to you if you put a negative 1/6 instead of a 1/6, but it's wrong because it's supposed to be positive 1/6. On 5, the amplitude is 2, because that's what's in front of cosine. To find the period, we're going to have to do 2 pi over what's in front of x, which is not just 3, it's actually 3/4. So to work this out, we make 2 pi be over 1, and we times it by the reciprocal of 3/4. So we flip 3/4 and get 4/3. That's how we divide fractions. So back in 6th or 7th grade or whenever it was that you learned how to divide fractions, we left the top alone. I just made it a fraction here, 2 pi over 1, and then we times by the bottom number flipped over. So now that I'm multiplying, I just multiply across the top and get 8 pi, multiply across the bottom and get 3. So that's the period of my function is 8 pi over 3. Now we're going to start in on stuff from chapter 5. So we're going to factor 3 different things here. And I think a lot of us find it easier if we change these to an algebraic expression. So if cosine is squared, I can replace that with x squared. And then plus 11 cosine theta would just be plus 11x. And then this plus 10, it'll stay plus 10. What we basically did is we said, I'm going to make x be cosine theta, and then work out what that would make this. So when I factor, when I have 3 terms, what I'm doing is saying what multiplies to get my last number, and that adds to get 11. So we first have to think about what multiplies to get 10, which we don't have a lot of choices. Which of these things adds to get 11? 1 and 10. And so now that it's factored, I'm going to put the cosines back. So this is going to be cosine theta plus 1 and cosine theta plus 10. And that's my answer. On 7, I'm going to do the same thing. This time it's tangent, but I'm just going to make tangent be x. So this is 5x squared minus 7x minus 6. And personally, the way I like to factor when there's a number in front of x squared is to slide and divide. So I start off by sliding the 5 to the negative 6. And when I do that, I multiply those numbers together so that I get negative 30. And then I say what I did in the last one over here. I put 2 parentheses and go, what multiplies to get negative 30 that adds to get negative 7? So multiplies to get 30, have all of these choices. Since it's negative 30, I'm going to subtract to get negative 7. And so that means I want 3 and 10. I want a negative 7, so that's negative 10 and positive 3. But we're not done yet, because if I slid the 5 earlier, this is where I would divide by 5. And the way this works is if it simplifies, I'm going to simplify it. So this is x minus 2. And if it doesn't simplify to where it's not a fraction anymore, like 3/5, I'm going to move the 5 in front of x. So this is 5x plus 3. So I'm almost done, but I'm not quite. I need to change my x's back to tangent theta. So this is going to be tangent theta minus 2 and 5 tangent theta plus 3. I'm going to change on 8. I'm going to do the same thing, but see, this has 2 different trig functions. So if I change this to like 9x squared, I can't change this to x squared also. I'd have to use a different letter like y squared. To factor this, what I do is I split up the 9x squared into the beginning of my parentheses as 3x and 3x. And I split up the second thing into 4y and 4y, but one of them is going to be positive and the other one is going to be negative. Because what we're trying to do is get 2 things that multiply to get 9x squared, which is 3x and 3x, 2 things that multiply to get negative 16y squared, which is 4y and negative 4y. And so what happens is that if I were to FOIL this now, my outer and inner terms would cancel out, which is how we end up with only 2 terms here to start off with. So it's called the difference of 2 squares. I'm subtracting 2 things that I can square root, and so that's what I get. Now I'm going to change back to tangent and sine. Make sure you change x to tangent and y to sine. So this is 3 tangent theta plus 4 sine theta, and then 3 tangent theta minus 4 sine theta. And if you put those in the opposite order, that's fine. That's still the same thing, but that's how we factor. This next section is a bunch of trig equations that we're going to solve. And so what we're looking for when we're solving trig equations is only having one trig function to the same power. So like this just has cosine theta and 10 just has sine theta. If that's the case, then I can just solve for that cosine theta by doing things like dividing 4 on both sides or adding or subtracting numbers if I need to, so that this is cosine theta equals, if I have negative 2 over 4 and then the square root of 2, I can cancel on the negative 2 and the 4, and that's because they're both outside of our square root. So I can't cancel with the 2 that's under the square root, but the 2 outside, yeah, totally. So this is negative square root of 2 over 2. Cosine on the unit circle is our x value, and so we're looking for where our x value is negative square root of 2 over 2, and that happens in 2 places. over in the second and third quadrant. One of them is 135 and the other one is 225. You should always be looking for two answers unless you're on your quadrant lines, and then sometimes we only have one answer. If you get something, if you're looking and you see that it's like 90 degrees or something, then it might be that there's only one answer, but you still need to check and make sure. On 10, I'm just going to divide by -4, so I get sine theta equals 1/2. So sine is my y value on the unit circle. And so if my y value is supposed to be 1/2, that happens two places. It happens at 30, and it also happens at 150. So my answer would be C. On 11, we want to get tangent theta by itself, and so this -2 that's in front, it's -2 plus tangent theta, not times tangent theta. So I'm going to add 2 to both sides, and so that gives me 1 equals tangent theta. Tangent on our unit circle is y over x, and so that means we're trying to find the points on our unit circle where the y value over the x value simplifies to be 1, and so that has to happen where our x and our y value are the same. So either square root of 2 over 2 comma square root of 2 over 2, or negative square root of 2 over 2 over negative square root of 2 over 2. And so that happens at 45 degrees and at 225 degrees. On number 12, I have more than one sine x, but neither of them are squared. They're both just regular sine x, which means I can add this sine x over to the other side to get them to be together. So I add sine x over, and so sine x plus sine x gives me 2 sine x. You might have thought that gave you sine squared x, but no, if I have one sine x plus another sine x, there's 2 sine x's. And that equals square root of 3, so I just need to divide both sides by 2. And I get that sine x equals square root of 3 over 2. So I look at my unit circle, sine is my y value, so y is positive square root of 3 over 2 at 60 degrees, as well as at 120 degrees. So that means my answer is A. On 13, I have more than one tangent squared x, and so I need to start off by getting them on the same side. You can either subtract the tangent squared x over to the left or subtract the 4 tangent squared x over to the right. It is technically faster to subtract 4 tangent squared x over to the right, because if you do it the other way, you'll have to add 1, and this way we don't have to add 1. So this is -1 equals 1 tangent squared x minus 4 tangent squared x will be -3 tangent squared x. And then I'm going to divide both sides by -3, which gives me positive 1/3 equals tangent squared x. So if I have a squared, then the next step is going to be to square root both sides of my equation. So I'm going to square root and square root. When I square root to solve in an equation, I have to put plus or minus. The square root of 1 is 1. The square root of 3 is square root of 3. So I get tangent x equals positive and negative 1 over the square root of 3. Now, a lot of people have trouble with this one. I need to know what points on the unit circle, if I put y over x, will simplify to 1 over the square root of 3. If I look at the points on my unit circle, almost everything is over 2. So what's happening is that both of these things could have been over 2, and those 2's would get canceled out since it's happening on top and on bottom. So what I'm really looking for here are points that are square root of 3 over 2, comma 1/2. The 1/2 is on top and is our y value, so it's going to be the second part of the point. And I want all of the places this happens where it's any combination of positives or negatives in order to get this plus or minus. So that's 4 answers: 30, 150, 210, and 330. So, and it's really important we put the plus or minus sign, otherwise we would have only put 2 answers instead of 4. On 14, we need to solve for cosine squared x. This doesn't factor, or at least not very well. It's not really that helpful to factor it. As long as there's only a single cosine squared x, then it's faster and easier to just add 3 and get 4 cosine squared x equals 3, and then divide by 4 and get cosine squared x equals 3/4. Then I'm ready to square root, and so I get cosine x equals square root of 3 over 2. Oh, I forgot my plus or minus sign because I square rooted. So I'm looking for all the places where x is positive or negative square root of 3 over 2, which actually happens to be the same places that on the previous problem, since there our x had to be square root of 3 over 2. So that means my answer is C, because it's 30, 150, 210, and 330. On 15, this is different. It's the only one of these equations on here that's like this, but because I have a sine squared x and a sine x, I'm going to have to factor this, and since I have to factor it, I need to add the 1 so that it's on the same side as everything else. All of our other problems, we were able to just get sine squared or sine x alone, but I can't do that because I have a sine squared and a sine x. So I get this when I add 1 over, and now I'm going to just change these to x's to make it easier to factor, just like we did earlier in the video. So I'm going to need to use slide and divide, because there's a 2 in front, so this is x squared minus 3x plus 2. I'm going to split it into 2 parentheses and say what multiplies to get 2, that adds to get negative 3, which is negative 2 and negative 1. Then I need to divide by the 2 that I slid earlier, so that I get x minus 1 and 2x minus 1. But instead of x, remember this is supposed to be sine x. So I'm actually getting sine x minus 1 and 2 sine x minus 1. And now I'm ready to actually solve this. So I need to set each parentheses equal to 0. This is a skill that we do in Algebra 2 when we're solving quadratics. And one way to solve quadratics is by factoring and setting equal to 0. And so I'm going to add 1 to both sides and get sine x equals 1. And then the other one I'd add 1 and then divide by 2. So that gives me sine x equals a half. So on my unit circle, because these are both sine, I'm looking for where y is either 1 or 1/2, which it's 1 at 90 degrees and only at 90 degrees. It's 1/2 at 30 and at 150. So I only get 3 answers on this one, and that happens anytime that I have to look at one of my quadrant lines like I did. Like sine is up here at 90 degrees, so anytime it's at one of these, like the 4 cardinal directions, northeast, south, or west, anytime it's like that, there's a chance that we'll only get 1 answer and not 2. Last of our equations, this doesn't have a regular cosecant x, so I don't need to factor. I just need to add 2 to both sides, so that I get cosecant squared x equals 2. I'm going to square root both sides. I get cosecant x equals positive and negative square root of 2. Now the issue with this is cosecant is 1 over y. So if I want to know where 1 over y is positive or negative square root of 2, it's easier if I flip this. If I flip 1 over y, I get y. But if I flip one side of my equation, I have to flip the other. This would be 1 over the square root of 2 when I flip it. That's still not really as helpful as we might like, because that's not on the unit circle. But remember, I would rationalize that and get plus and minus square root of 2 over 2. And finally, I have something that is on my unit circle. So y is positive and negative square root of 2 over 2 in 4 places, which means it has to be C because it's the only choice that has all 4. Don't get thrown off by this whole no solution thing. None of the problems that we've done have been no solution. So it's a really, really not smart choice to pick if you're just guessing. Any other option would be better than picking no solution, since none of our problems have had no solution as an answer. Now we're going to simplify some expressions, and what we need to do is look at our trig identities in order to do this. So whenever I say that something equals something else, that's where I'm getting it from, is trig identities. So like on 17, I have sine x times cotangent x. A general strategy is don't change sine, make it be over 1, but don't actually change it. I can technically change it to 1 over cosecant x, but I don't want to because it's not going to actually help me. But do change things like cotangent, and I'm not going to change cotangent x to 1 over tangent x. I'm going to change it to cosine x over sine x. Now the reason that I do that is because now we have a sine x on top and a sine x on bottom that cancel and leave us with cosine x, which is our answer. So I'm going to pick A. On 18, cosecant x I can change to 1 over sine x, and secant x I can change to 1 over cosine x. And then, because I have a fraction over a fraction, the way I divide fractions is leave the top alone and flip the bottom. So you'll see nothing cancels, so I'd have to write this as cosine x over sine x. That's not an answer choice, but look at your identities, because cosine x over sine x equals cotangent x. So my answer is B. 19, we're going to need to factor. So you may be looking at like secant squared x minus 1 and saying, hey, that's tangent squared x, which is true, but that won't actually help us to simplify this. Because secant x minus 1, you can't say that equals tangent x. You're not allowed to take the squareds out of the Pythagorean identities and have them still work. So our best strategy here is to factor the top. This is like having x squared minus 1. So it factors into a difference of 2 squares. So x plus 1 and x minus 1. So we put secant back in and get secant x plus 1, secant x minus 1. And then on the bottom, we still have secant x minus 1. And so that was helpful because those cancel, and we're left with secant x plus 1 as our answer. There's a thing that a lot of us like to do where like we pretend like things cancel that don't really cancel, like the squared and the secant or something. I don't even actually really understand what exactly people think when they do that, but like you need to be careful because I feel like that would make you think that it's A, but it's not A, it's B. So we could try the same thing on 20 and make this 1 plus sine x and 1 minus sine x, but that's probably not going to be as helpful in this case because we don't have 1 plus sine x or 1 minus sine x on the bottom to cancel out. Instead, I should look at my identities and say 1 minus sine squared x is cosine squared x. And then I'm going to change cotangent x to cosine over sine x. In fact, I'm going to erase what I have and go ahead and make that change so I don't have to rewrite a step. Cosine x over sine x. So what we're going to do is divide these fractions. So cosine squared x is over 1, and that's going to stay cosine squared x over 1. I'm going to flip sine x over cosine x. So something cancels. Not all of my cosines cancel, but the squared part cancels out, so that all I have left is cosine x from the first fraction and sine x from the second fraction. And those are being multiplied together, so my answer is A. these last three problems are identities. We're proving or verifying that algebraically by manipulating only the left side to make it look like the right side. So it's kind of like they're telling us the answer. So all they want is for us to show the work. And so even if we're the type of person who doesn't like showing work, your answer is your work, so you need to show as many steps as possible. So I'm going to change some things over here on the left side. Secant x I know is 1 over cosine x. 1 minus sine squared x, I look at the Pythagorean identities and I say, hey, that's cosine squared x. So this actually works out really quickly because 1 over cosine x times cosine squared x over 1, the squared and the cosine cancels, and that leaves us with cosine x. So there really wasn't a whole lot of work to show there. I like to end my proofs like this with a smiley face, so there you go. On 22, the best way to start this is by saying, here is a term, and here is a term, and they have a cotangent x in common that we can take out. If I take the cotangent x out, then what I'm left with is sine squared x plus cosine squared x. Now, you have to be careful when you're doing that, because if one of these was just cotangent x, remember we have to put a 1 to whenever we factor out to show there was something there. So keep that in mind. Like if this had just said cotangent x and I take out the cotangent x, I have to write a 1. But anyway, sine squared x plus cosine squared x is an identity. So that equals 1. So I get cotangent x times 1, which is cotangent x, which is what I wanted. That also was pretty quick. But on both of these, it was quick because no, not on both of these. On 22, it was quick because I factored. There's other ways of going about this problem that are harder, and you still end up having to factor anyway, so it's kind of like, well, I should probably just factor at the beginning and make it easier on myself. So on 23, I don't have anything in common here and here, but I can change cotangent to cosine x over sine x and see if that helps. So I'm going to make this sine x over 1 plus cosine x over 1 times cosine x over sine x. Now, it may not look like that helped because nothing cancels, but I am going to combine those cosines on top into cosine squared x over sine x. And now the best way to go, because it's a plus sign, I can't cancel the sine x's out. That's only with multiplication. But I can get a common denominator of sine x and add the fractions together. So that gives me sine squared x on top of the first fraction, and I still would have cosine squared x on top of the second one. So when I add my fractions together, those both end up on top with a plus in between. And on bottom, I put my common denominator, which was sine x. I don't put sine squared x or 2 sine x. Like when I add a half and a half, I get 2 halves. I don't get like 2 over 4. That doesn't make any sense. So the common denominator stays the same. Then I look for identities. Sine squared x plus cosine squared x is 1. So I have 1 over sine x, which is cosecant x, which is what I wanted. So I draw my smiley face. So this has been solving trig equations and using trig identities and all kinds of good triggy stuff.